Wonderful. So far we have learned how to do simple arithmetic by using the mathematical operators to just add, subtract, multiply numbers together and do a little more complex operations, such as calculating the length of a circle and the area of a circle by combining multiple of those operations together, one after the other. Now, you can imagine how, depending on the operations that we might be doing, this can get actually really complex. It can get, it can become, they can become operations where we have to chain actually a lot of multiple operators one after the other. And depending on what we're doing, it may actually get a little, messy or busy in our screen. So it turns out that when we want to create more complex calculations, we have different options. We have different options instead of using all these components and chaining them together. We can do it in a more elegant and perhaps even easier to understand visual way than using components. And we have this alternative called using expressions. So if you go to the math tab and you go to the scripting tab, you can see that we have the expressions component. This component is perhaps a little daunting because it's much larger, but what this component basically does is that it gives you a way to write mathematical equations, if you will. It's not exactly that, but it kind of looks and feels like mathematical equations. So the way this works is that, first of all, you have a set of inputs here, and then you have the window where you can type in your equations. So for example, let's say that I want to mimic the calculating the length of a circle. If that's what I want to do, the only parameter that I need to calculate the length of the circle is the radius, right? So what I can do is I can zoom in the component, and you can see that as I zoom in the inputs parameters, these icons pop up that allow me to add or remove inputs to the component. So what I'm going to do is I'm going to right click on this one, and I'm going to change the value of x, and I'm just going to type here radius, so that my variable is called radius, or it could be called r. And then I'm going to remove the y because I don't need it. I just need radius as the input. And then what I'm going to do is I'm going to double click here on format, and you can see that this expression editor pops up. What this expression editor does is that it gives me a way of typing here with pseudocode, with more of a literal expression. It allows me to write what do I want to do for a calculation. So if I want to calculate the length of a circle, the equation, as we saw before, is 2 times pi 2 times the radius of the circle. So what I can do here is I can type 2 times, and I could do 3.14159 times the radius. Okay, so that could be one way to go. And then if I do that and I press OK, you can see that I have an error. Let me see if the problem is, yes, exactly. The problem was that I wasn't giving it any information here. And then if I plug in here a panel, you can see that the result is almost identical to what I had in the previous one. It's not identical because, well, this one is basically rounded here, but I'm also using a manual approximation of the number pi that I just typed. I just hard-coded that. Better than that is using a built-in form of the number pi. So for example, if you see here in the expression editor, you can see that I have a lot of things. I have ways of typing functions. I have ways of typing constants. I can choose operators, and I can do simple operators. So for example, multiplication, you can see that it's the same. If I click multiplication, the symbol is just the asterisk, right? Or if I press x to the 8 square, it gives me like a square operator. So what I can do is I can remove this, and I can click here to add the value of pi. And you can see that this symbol pi shows up, which contains a much closer approximation to that value. And now the two values are clearly identical. So now I can turn this into a group, and this is the circle length. All right. What is the advantage between doing this and this? Well, I I think it's just visual, or it's just for the sake of keeping things a little tidy. Um, for me, for the naked eye, perhaps understanding what's happening here might be easy, but if the equation is a little larger, it can get complicated. Whereas for me as a human, at least for me that I'm used to equations. For me, it's much easier to read this expression on one go. Similarly, for the circle area, I could just drop an expression component and say, well, I also need the radius as well as an input. So I'm going to remove this. I'm going to change this to r, for example, or let's just be a little radius, okay? And then what I'm going to do here in the expression, I'm going to mimic this part here. So I'm going to say what I want is to take the number pi and multiply it by the radius and squared, like that. Or I could also do radius times radius. It doesn't matter. So if I do that, then you can see that now I can plug in my radius, okay? And then I can plug in my other one, and the result is the same here. So for me, as a human, I find this a little more elegant, a little easier to read than this mess of components. And again, this is for a very simple scenario. It can get more complex. Should we take a look at a more complex example? For example, let's take a look at, for example, how do we calculate the area of a sphere? Well, it's actually the equation is not that much more complicated than what we've had before. So I'm just going to start moving this to a nicer. So we have the circle length. We have the circle area, and you know that I like keeping things tidy. All right, so we have the circle area. I'm going to copy the whole thing, and I'm going to say, what is the sphere area? And then the equation of the area of a sphere is 4 times pi radius squared. So let's do this here. So this is 4 times pi times radius squared, and that is the area of a sphere. What about if we do the volume of a sphere? So let's take a look at how that looks like. So the volume of a sphere is 4/3 of pi times pi cubed. So how do I do that? Well, so let's say 4 divided by 3 times pi times radius cubed. Well, I could do radius cubed here, but what if I didn't have this shortcut? Well, it turns out that actually, if you look here in this panel, you can see that you can consult a list of all the functions that are available in this language. So I'm not sure if you can see, I can't really zoom on this one, but what you can see is that more complex mathematical operations such as sines, cosines, square roots, absolute values, means, etc., all of those can be accessed by their literal expressions, like for example, cosine of x, sine of x, exponential of x, etc., etc. So this is a really useful guide to more complex operations. And if we look closely, for example, we can see that here I have power. So pow x and y, which means that returns a specified number raised to a specified power. If we didn't have this shortcut, what I could do is I could say, I want to calculate the power of radius elevated to the number 3. And this is how, in this kind of function call sort of literal expression, I can access more complex operations. So if I do that, then you can see that this would be the volume of an area with radius whatever, right? And again, for me, this is much easier and much more elegant to read than if we had a similar expression in terms of arithmetic components connected with each other. And you know that I have a little bit of OCD, so I'm going to start like packing all of this here together, and I want to take this and all of this, I'm going to align them to the left. So that's going to be this arrow here, And oh, look how nice and tidy this is looking to me right now. Huh? It's wonderful. Okay. And I think I forgot to add this component here. Yes, so that we all can see that these are expressions. But what if we actually want to calculate a really, really more complicated operation? So are you familiar with the quadratic formula? If you haven't, the quadratic formula is basically a way of solving an equation that has this expression. The expression being a polynomial that with a variable x, right? And then three constants, a, b, and c. And if those equal 0, the challenge here is to find what the value of x is, so that this whole equation equals 0. So imagine you have something that is like 2 times x squared plus 3 times x plus 5. The challenge here is to find what values of x are satisfy the equation that all of this together equals 0. And the way to solve that is with this expression that it's a little more complicated. To do it manually with Grasshopper components, it would take a while. So that's why we can try to implement this by calculating, excuse me, by calculating, excuse me, by calculating the value of x. So for example, let's say that I were to input here a slider. So I'm going to type here number slider, and then I'm going to right click to customize the values, and this is going to be something that is going to go from minus 100 to positive 100 with 2 decimals, for example. And then I am going to crank this up, and this is going to be the value of, oops, sorry, this is going to be the value of the constant a. It's a little too big, so I'm going to copy paste it 3 times. I'm going to arrange them, align them, and this is going to be now the value of b, and this is going to be the value of c. And let's say that this is going to be 2, this is going to be 4, I'm going to double click here, 4, and this is going to be the value of 5, for example. The challenge here is, given these 3 constants for the expression 2, 4, and 5, which value of x satisfies that this equals 0? So we use this formula here. So how does that work? The formula is, we would write here an expression, first of all. So I'm going to double click, and I'm going to search, and I'm going to drop here an expression. I'm going to change this. So this is going to be a, this is going to be b, and then I'm going to add a third one, which is going to be c. And then I'm going to plug them in here, a, b, and c. And I'm going to try to write this expression in my expression component. So can I actually keep those things in parallel? Yes. So I'm going to have my expression here, and then the expression is going to be equal, x is going to be equal to minus b, all right? And then you see we have a plus minus symbol. This is because the equation has 2 solutions. Solutions that are this expression with a positive value and this expression with a negative value. So we're going to start first with the positive one, right? And then we need to calculate the square root of all of this. I don't have a square root symbol here. So what I can do is I can go to the list and find that there is a function here called returns the square root of a specified number. So I'm going to use sqrt, and I'm going to open and close parentheses. And inside, I'm going to specify b squared. So this can be b squared, or it can be b times b. It doesn't matter, whatever you want to do. I'm just going to do b squared because it looks a bit more elegant, minus 4 times a times c. And remember that I'm adding these white spaces just because it looks a little better, but they're not necessary. It's just a flavor. And I'm also, now I have to divide everything by 2 times a. However, remember that in computer programming, just like in mathematics, there is this concept called operator precedence, which means that some operations have more importance and they are executed before others. So if you remember from math class in high school or school, wherever you did that, you might remember that multiplications and divisions have precedence over additions and subtraction. So if I were to write this like this, what would happen is that this square root would be divided by 2 times a, and then all of that together will be added to minus b, which is not what I want. What I want is this whole thing to be divided by 2 times a. So that's why I need to remember to add a parenthesis here and add another parenthesis here, so that I force all this chunk together to be divided by 2 times a. As I do that, I have my expression here, which imagine what this would have entailed to do manually with just components. All right, and then I'm going to paste this here, and this is going to be not a number because I actually don't know what's going on. Why is this not a number? Let me check this out. Oh yeah, very simple. I had totally forgotten. This is probably not a number because it's a value that cannot be computed, because the result of this part here is probably a negative number. And if it's a negative number, remember that we cannot calculate with real numbers, we cannot calculate the square root of a negative number. We would get into imaginary numbers and blah, 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 and that's like a completely different deal. To make sure that we check if that is the truth, I can just copy paste and I can change this expression to just calculate what's inside of the square root. So just that. And if it is a negative number, you see, then this will be not a number. And as soon as I modify this to make it a positive number, you can see that we get the result. You see? So I'm just going to say, for example, this is going to be minus 10. All right. And now this is going to be one of the results. Wonderful. And what about the other one? Well, the other one is going to be the exact same one, but negative. With this part, this part is here is going to be a negative number. So that's going to be this one here. And maybe for the sake of simplicity or visual, I'm just going to plug both into the same. I'm not going to do that. So never mind. So I'm just going to have the two results here. And this is going to be the quadratic formula. All right. And these are going to be the inputs. Wonderful. So this is great. So this is the way that I typically like to do more complex arithmetic. I like to use the expression component. To be honest, I barely use any of the regular mathematical operators anymore, because I just liked the elegance and how easy it is to read and to write this expression, and also the power that I have to more additional components and more additional functions that I don't have in the Grasshopper toolbox. So this is the way we do advanced arithmetic in Grasshopper. So thanks a lot, and let's take a look now at other topics. For example, how do we make actually basic geometry inside of Grasshopper? Let's take a look at that. See you in the next video.